Welcome to The Explainer. So let's just jump right into it. We are living in a time where large language models, or LLMs, truly feel like magic, don't they? I mean, you can ask an AI to write a Shakespearean sonnet about a toaster, you can have it generate hundreds of lines of Python code, or even summarize a massive, dense legal document in just seconds. It is absolutely incredible. But if you actually use these tools on a regular basis, you know for a fact that this illusion of perfect intelligence definitely has its limits. And that brings us to the massive elephant in the room. Why do these incredibly advanced AI models still completely fail at basic math and logic? Think about it. You can have a model that writes a totally flawless essay, but then you hand it a middle school math word problem, and it just completely fumbles the numbers, or it skips a totally crucial logical step. It's wild. Well, today, we are going to explore exactly why that happens. And more importantly, we're going to break down a specific prompting technique from Learn Prompting that acts as a super powerful antidote to this exact problem. Here is our quick roadmap for today's explainer. We are going to kick things off with the zero-shot problem. Then we'll jump into Enter, Plan, and Solve. After that, we'll cover the 2 steps to success, followed by the PS Plus upgrade, and we'll wrap it all up with results and limitations. All right, let's dive right into Section 1. The zero-shot problem, when step-by-step fails. So if you've been hanging around the AI space for a bit, you've almost certainly heard of the magic phrase, let's think step-by-step. Now, this is known as zero-shot chain of thought prompting, and honestly, it was a massive breakthrough. Researchers figured out that by simply appending those exact words to the end of a prompt, the models were basically forced to generate their intermediate reasoning steps before just blurting out a final answer. And it worked. It dramatically improved performance on all sorts of multi-step tasks. But as people kept experimenting, they quickly realized this method actually has a few fatal flaws. Yeah, it turns out the whole think step-by-step method has 3 very distinct pitfalls. First up, calculation errors. The AI might actually set up the equation perfectly, but then completely botch the basic arithmetic. Second, we have missing step errors. This is where the model might jump straight from step A to step C, entirely skipping step B, which, completely ruins the logic of the whole answer. And third is semantic misunderstanding. That's when the model just flat out misunderstands the meaning of the words or the scenario you gave it. Now, for today, we are heavily focusing on solving that tricky middle issue, the missing step errors.
Which leads us perfectly into Section 2, Enter, Plan, and Solve, planning before executing.
Okay, so the core difference here is entirely structural. Instead of relying on the old standard, let's think step by step, the Plan and Solve, or PS prompt, significantly expands our instructions. Check this out. It reads, let's first understand the problem and devise a plan to solve the problem. Then, let's carry out the plan and solve the problem step by step. By expanding our prompt like this, we are literally forcing the LLM to separate its brain process into 2 very distinct phases, planning and then execution. Because when the model has to explicitly write out a plan first, it is way less likely to suffer from those missing step errors we just talked about. It's basically like forcing it to draw its own roadmap before it even puts the car in drive. So, how do we actually pull this off in practice? Let's get into Section 3, 2 steps to success, implementing PS prompting. The absolutely crucial thing to grasp here is that Plan and Solve isn't just one single message you fire off to a chatbot. It's actually a structural process. Implementing this requires 2 distinct phases, which is super important if you're trying to use this in your own automated workflows. Step 1 is inference. This is where you feed the LLM your question along with that nice long PS prompt we just looked at. The model's going to spit out its plan, its step-by-step reasoning, and an initial answer. But because we want to use AI in automated systems where we need clean data, we absolutely have to do step 2, answer extraction. We need a way to isolate just the final answer from that massive wall of text the AI just generated for us. So, to get that perfectly clean extraction in step 2, here's what you do. You take your initial prompt, you append the AI's entire generated response from step 1, and then you add this incredibly specific, highly effective phrase right at the very end. Therefore, the answer, Arabic numeral is. When you feed that whole package back into the LLM, it forces the model to ignore all of its previous chatty, conversational text and cleanly output literally just the final number. So if the answer was 60%, it won't give you a paragraph, it'll just say 60. This simple 2-step dance is exactly what makes PS prompting so remarkably effective for building reliable automated systems. But wait, we have a plot twist. Let's hit Section 4, the PS Plus upgrade, defeating calculation errors. Because as it turns out, while standard PS prompting is fantastic for stopping the AI from skipping steps, it still fails spectacularly at complex calculations. So it is time for a boss battle.
To really put our AI to the test, the source material uses this exact math word problem. Let's read it together. Grace weighs 125 pounds. Alex weighs 2 pounds less than 4 times what Grace weighs. What are their combined weights in pounds? All right, this is a classic multi-step algebra problem, right? You have to figure out Alex's weight based on Grace's, and then the part people always forget, you have to remember to add them both together at the very end. While when handling this problem with just the standard plan and solve prompt, the AI actually created a really great plan, but it completely fumbled the actual math. It super confidently answered 497 pounds. It basically tried to calculate 125 plus 4 times 125 minus 2 and just totally messed up the order of operations and the basic arithmetic. But look at the PS plus output. It successfully substitutes the variables and calculates everything perfectly, arriving at the correct answer of 623 pounds. So the big question is, how on earth did we get from that initial failure to this success?
We got there by slightly modifying the prompt to create what's called PS plus. We explicitly told the model to extract relevant variables and calculate intermediate results. And get this, we even explicitly commanded it to pay attention to calculation and common sense. Now I know, it sounds almost silly to have to remind a literal supercomputer to pay attention to its own calculations, but you have to remember, LLMs are fundamentally text prediction engines, so giving them explicit instructions to focus on arithmetic forces them into a much more analytical mode. And that simple little addition is exactly what fixes those crazy math errors.
Which brings us to our final section, Section 5, Results and Limitations, the data and the catch. The hard data on this clearly validates the technique. Across the board, PS Plus officially outperforms the older zero-shot chain of thought method. It shows some seriously significant improvements in both symbolic and math reasoning tasks. It also completely excels in established common sense datasets like CSQA and Strategy QA. And just as we promised, it successfully reduces both those annoying missing step errors and even to some extent the semantic understanding errors, all because the AI is being forced to slow down, build a plan, extract the variables, and calculate its intermediate steps. But as with literally all things in AI, we have to have a reality check. It is not a magic wand. There are definitely limitations. First off, LLMs are still highly sensitive to prompt wording. Just changing a few words in your PS Plus prompt can drastically alter the final output. Second, because of that intense sensitivity, it still takes considerable manual human effort to design and test the perfect trigger sentences for your specific use case. And finally, while it definitely helps, PS Plus does not completely resolve semantic misunderstandings. If the AI just fundamentally misunderstands the core concept of your prompt, no amount of planning is going to save it from generating a flawed answer. Which leaves us with this final, somewhat provocative thought to ponder today. When an AI solves a complex problem absolutely flawlessly using a PS Plus prompt, how much of that reasoning actually relies on the sheer computational power of the model itself versus how much of it relies on the careful, highly structured intent of the human who prompted it? It's a pretty intricate, fascinating dance between human logic and machine execution, isn't it? Thank you so much for joining me for this explainer. I highly encourage you to go test out the PS Plus method in your own workflows and see firsthand the massive difference a good plan makes.